Welcome, future scientists. Today we're diving into the hidden world where electricity meets chemistry. We know electricity powers our gadgets, usually through metal wires. But what happens if electricity travels through liquids? Does it just stop, or does something chemical happen? Here's the secret. Electricity can actually transform substances as it passes through certain liquids. This is called the chemical effect of electric current. It's not just about power, it's about changing matter itself. Everyday things like shiny bike handlebars or purified metals rely on this principle. Water, especially with dissolved salts, can conduct electricity and trigger chemical reactions. When electricity interacts with ions in a liquid, it causes visible changes, bubbles, color shifts, even new materials. This concept connects physics and chemistry, showing how science is all about connections. Ready to see how electricity can change the world around you? Let's get started. Not all liquids let electricity flow. Some are conductors, others are insulators. Conductors, like salt water, lemon juice, and vinegar, have lots of ions, charged particles that carry electricity. Insulators, like pure distilled water, oil, and alcohol, lack these ions and barely conduct electricity. It's the dissolved substances, salts, acids, or bases, that make a liquid conductive. So tap water conducts, but pure water does not. If you dip a circuit into a conducting liquid, the bulb lights up. In an insulator, nothing happens. Conducting liquids are called electrolytes. Non-conducting ones are non-electrolytes. The key difference? Free ions. Knowing which liquids conduct is the first step to understanding chemical effects. This determines whether electricity can trigger a chemical reaction. So, next time you see a liquid, ask, does it have ions? That's the science behind the spark. How do we know electricity is causing a chemical reaction in a liquid? Look for clues. First, gas bubbles, like hydrogen and oxygen, form when electricity splits water molecules. Second, color changes, such as a blue copper sulfate solution fading, show new substances forming. Third, metal deposits, like copper coating an electrode, prove atoms are moving and changing. These visible signs are proof of chemical reactions driven by electric current. No microscope needed, just your eyes and curiosity. Gas bubbles, color shifts, and metal coatings are the smoking guns of chemistry in action. Each clue tells us electricity is transforming matter. This is the heart of the chemical effect of electric current. Science is all about spotting these changes. This process has a name: electrolysis, using electricity to split substances apart. Here's how it works. You have a conducting liquid, electrolyte, and two electrodes. The positive electrode is the anode. The negative is the cathode. When current flows, positive ions move to the cathode, negative ions to the anode. At the cathode, positive ions gain electrons and become neutral atoms, often forming metal deposits. At the anode, negative ions lose electrons, sometimes forming gases. Classic example, electrolysis of water. Add a little acid or salt to water, pass electricity through, and you get hydrogen gas at the cathode and oxygen gas at the anode. You're literally splitting water into its elements. This process is used to make hydrogen fuel and pure metals. Electrolysis is a powerful tool in science and industry. It's all about using electricity to create chemical change. Simple setup, amazing results. That's the magic of electrolysis. Let's use electrolysis for something practical: electroplating. Electroplating coats objects with a thin layer of metal using electricity. Why? To make things look expensive, prevent rust, or add shine. Here's how. The object to be coated, like an iron spoon, is the cathode. The metal to coat with, like copper, is the anode. Both are dipped in a solution containing metal ions, like copper sulfate. When electricity flows, metal ions move from the anode to the cathode, forming a thin, even layer. The longer the current runs, the thicker the coating. This process lets us combine the best properties of different metals. Strong but rusty steel can be coated with shiny, rust-resistant chromium or nickel. Electroplating is precise, practical, and everywhere. It's science making everyday objects better. All thanks to the chemical effects of electric current. Electroplating isn't just for the lab, it's everywhere. Shiny bike handlebars, car bumpers, kitchen faucets, and jewellery all use electroplating. Chrome-plated steel parts resist rust and look great. Faucets and shower heads are often brass or zinc, coated with chromium or nickel for durability and shine. Even affordable jewellery is made by electroplating a base metal with gold or silver. Electroplating protects, beautifies, and saves money. Silver items are often coated with rhodium to prevent tarnishing. This process keeps things looking new and lasting longer. Next time you see something shiny, remember, it's science at work. Electroplating is a perfect example of chemistry and electricity teaming up. Look around, science is everywhere. The chemical effects of electric current power modern industry. Electrolysis extracts and purifies metals like aluminum and copper, essential for cans, planes, and wiring. It's called electrometallurgy, and it's how we get pure metals from ores. Electrolysis also produces chlorine gas, used to disinfect water and keep pools safe. Clean tap water. Thank electrolysis. Understanding these processes helps you see how science shapes the world. From electronics to jewelry, electricity and chemistry work together everywhere. This knowledge connects different fields of science and technology. It's not just for exams, it's for understanding the world. You're building a foundation for future innovation. Science is all around you. Now you know how it works. Ready for your exam? Here are the essentials. Remember, pure water is a poor conductor. Dissolved salts make it conductive. Know your terms. Electrolyte, conducting liquid. Electrode, conductor in the liquid. Anode, positive. Cathode, negative. Use the memory trick, panic. Positive. Anode, negative is cathode. When drawing an electrolytic cell, label battery terminals, anode, and cathode. For chemical effects, give examples. Gas bubbles, electrolysis of water. Color change, copper sulfate. Metal deposit, copper plating. Be ready to explain electroplating. Object to be coated is cathode. Metal bar is anode, both in a solution with metal ions. Example, to coat an iron key with silver, make the key the cathode, silver bar the anode, and use silver nitrate solution. When current flows, silver deposits on the key. Specific examples show deep understanding. Practice explaining steps clearly. These tips will help you ace your science test. Good luck, scientists! We've explored how electricity transforms matter, from splitting water to making shiny objects. The link between electricity and chemistry shapes our world. Jewelry, clean water, and more. Electrolysis and electroplating aren't just textbook topics, they're real-world science in action. Now, when you see a chrome faucet or sparkling bike, you'll know the science behind the shine. Curiosity and observation are your best scientific tools. Keep asking questions and experimenting safely. These principles are used by scientists and engineers everywhere. You're building a strong foundation for future discoveries. Science is everywhere. Keep exploring its secrets, stay curious, and keep your mind charged.